Okay, this is question 14 from the sample test. Somebody sent this in, and it involves these z-scores. And one of the most interesting things about z-scores is it takes everything that's normally distributed and makes it comparable. It kind of maps it all onto the same standard normal curve. Um, and it allows you to do, compare two people that competed in very different races and kind of say, well, who's the better of them? Another example might be, you know, if if I race in a race and I do well, but then my son also races in a race and he does well. Well, I'm of course going to be faster because I'm an adult and he's a kid, but we can actually compare adults and kids if we use the z-score by showing how much above the average I was and how much above the kid's average my son was. That's a kind of a useful way to compare those two things, because an absolute comparison would just always favor the adult. And it doesn't mean that I'm particularly good at running. It just means that adults are, far and away faster than young kids. Um, so that's what they're doing in this question. They have what Ted and Jane are in a yearly amateur auto race, and let's see. So the average finishing time was 185.93 minutes with a standard deviation of 0.304 minutes. The winning car was driven by Ted, who finished in 185.15 minutes. And the year's previous race had a mean finishing time with 111.5 was that minutes? Yeah, with a standard deviation of 0.136 minutes. The winning car that year, driven by Jane, finished in 111.33 minutes. And one reason that you wouldn't compare them directly is maybe the technology, the driving technology. The cars have gotten better. So even though Jane finished faster, right, than Ted does, it might be because she has a better car, not because she was necessarily a better driver. And so that's why we want to compare the z-scores, because the z-scores will kind of discount, the different technology. It will only compare Jane. How much better was Jane than the average in her year versus how much better was Ted versus the average in his year. So, okay, you don't have to do this this is a real simple calculation. You don't have to do this in a spreadsheet, but I thought it would be just useful for demonstration purposes. So if we take Ted's year, he finished with 185.15 minutes. Okay. Now the average time his year was 185.93. Okay. And just to compute the z-score, all we're going to do is take his time, subtract the average time, and divide by the standard deviation. That will tell us how many standard deviations he was underneath the average, right? How far below the average time was he? And remember, it's a race, so below the average is good here. So all we have to do is we would just take Ted's time, subtract the average time, and then divide by what's the standard deviation? It's 0.304. That's the standard deviation for Ted's year. Okay, so he's almost a little bit more than 2.5 standard deviations below the average his year. So that's really good. Now let's do Jane. Okay. Now Jane finished with 111.33 minutes, but the average time her year, right, was 111.5. Okay. And we're just going to do the same kind of z-score computation in the same way. So we're just going to take Jane's time and oh, forgot my equal sign. Take Jane's time, subtract the average in Jane's year, and divide by the standard deviation from her year, which was 0.136. Okay. And we see that she is, again, she's the winner. She finished faster than the average time, but not as many standard deviations faster as Ted did. So he kind of, what you want to think of is he blew the competition away really bad in his year, and she blew the competition away, but not as bad. So we would say Ted had a more convincing victory because he's got a lower z-score. Okay, so I hope that both explains how to compute the z-score and also why you would want to use the z-score to do something like this. You could also do it for different sports, like is Roger Federer better than Tiger Woods, right? Of course, you can't compare golf and tennis necessarily. There's no absolute comparison between the two, but you could ask how much better a tennis player Roger Federer was than the average tennis player versus how much better Tiger Woods was than the average golfer. So interesting things to do with z-scores.